Welcome to Study Loop.
So we are given a monoatomic gas of 1.55 moles. And we are also given two states, A and B, corresponding to pressure 455 Newton per meter square and volume 2 meter cubed and 8 meter cubed. So in a graph, in the graph, these points would correspond to 2, 455, which would be here, and 8, 455, which should be here. So let's use a different color. This is V1 and this is V2, blue. Now that we have this, we want to find out for A, the isobaric expansion from point state 1 to state 2. So isobaric means constant pressure, which means the Y component must be constant, which simply means that the process will go like this. Because Y is constant, our process must be parallel to our x-axis. That is it. This is our process. For part B, we want to find out the amount of work done. We know that work is simply integral P dV, and because the pressure is constant here, this becomes delta V. The pressure is 455 Newton per meter square times the volume change is 8 minus 2 meter cubed. Final 8 minus initial 2. If you notice, the units become Newton meter, and Newton meter is a joule. And this number turns out to be 2,730 joules. This is the amount of work done. Now, for part C, we want to think of a process where the system goes from 1 to the volume 8, state 1 to volume 8 meter cubed through an isothermal expansion. An isothermal expansion usually has PV equal to constant, which means it's of the form x times y is equal to constant, that is y is equal to k by x. So the process must look something like this. This is the curve. This would be the curve for y, xy is equal to constant. So our process must correspond to, it must start from here and it must go like this all the way until it hits 8 meter cubed. Now, at this point, let's use a different color. At this point, we want an isovolumetric expansion. That is, we want the volume to be constant and we want our process to go back to state 2, which means we simply have this process. Because the volume is constant, it must be parallel to y-axis. So instead of having this process, this one process, let's call it A, we have this process B where it goes like this and then takes another process C. Now, obviously, before we go ahead, let's look at the pressure here. The pressure value here, we know that because it's isothermal, PV is equal to PV is a constant, which means P1 V1 is equal to P2 V2, which means P2 is P1 V1 divided by P2. And by substituting our values, we can find that our initial pressure is 455 Newton per meter square. Initial volume was 2 divided by our final volume was 8. And this gives us 114 Newton per meter square. So this value would be 114 Newton per meter square. Now that we have this, for part D, we want to find out the change in internal energy during the process C. But if you remember, so we forgot to do something. In part B, we are also supposed to find the change in internal energy during the process A. We found the work, and the work was 2,370 joules. To find the change in internal energy, we use the fact that it's a monoatomic gas. For a monoatomic gas, it is 3 by 2 nR delta T, because we know that internal energy is 3/2 nRT for a monatomic gas. Now, this is equal to 3/2 nRT2 minus nRT1. We know that nRT2 and nRT1 are PVs. nRT is PV, so that's PV final minus PV initial. But we know that the pressure is constant, so we can simply pull pressure out. So that's V2 minus V1. If you remember, this is the work done, P delta V. So that's 3/2 times. Our work done was 2,730 joules, which turns out to be 4.1 into 10 cubed joules. Now that we have this, for part D, we want to find out the change in internal energy during the process B. Notice that this whole thing is process B. It comes all the way here and then goes like this. This is process B. So here, it's simple, because if you think about it, internal energy only depends on temperature. So as long as the initial final states are the same, the change in internal energy must be the same. So simply, delta E during process B must be equal to delta E during process A, which is 4.10 into 10 cubed joules. That is it.